Hey there, this is going to be a quick introduction to decibels or dBs and where you see them in vibration analysis. Decibels are ratios. We use them to see how much something has increased or decreased. Sometimes we talk about the voltage, for example, the voltage coming out of a sensor, and other times we talk about power. These are the formulas that we're going to use to understand decibels. Let's start with a common accelerometer. The sensor sensitivity is determined during calibration by putting 1 G into the sensor at either 100 Hz or 159.2 Hz and measuring the voltage output that the sensor provides. If we have a 100 millivolt per G sensor, we would expect the output to be 100 millivolts at this frequency when we put in 1 G. We would also expect it to not vary by more than 5 or 10% across what we call the linear range. Decibels are also used in filters, and filters are also heavily used in vibration. Usually the cutoff frequency of a filter is defined by what is called its half power point, and this is where it drops by 3 dB. And we'll see in a moment why minus 3 dB is half the power, and also why minus 3 dB would be 0.707 times the voltage. All right, it's time to break out your calculators and do some math. So why is 3 dB half the power? Let's use the formula where dB equals 10 times the log of P2, or the output power, divided by P1, or the input power. If we're saying that the power is half, that means P2 divided by P1 would be 0.5. In other words, we're getting out half the power than before. So let's plug that into our equation. We have dB equals 10 times the log of 0.5. And when we put that in our calculator, we get negative 3 dB. And it's negative 3 dB because the power is going down. We're reducing the amplitude. Now let's see why minus 3 dB is equal to 0.707 times the voltage. In the last example, we said P2 divided by P1 was 0.5, or half the power. We can use this formula where V is the square root of P2 divided by P1. And when we do that square root of 0.5, we get 0.707. So this is saying that if the power is half, the voltage will go down by a factor of 0.707. Now let's check that using the formula for dB. So we have dB equals 20 times the log of V2 divided by V1. If we say that V2 divided by V1 is 0.707, and we type that into our calculator, 20 times the log, 0.707, then hit the log button, then hit times, then hit 20, and you will get minus 3 dB. Okay, now let's go back to our example of a 100 millivolt per G accelerometer and see where voltage comes into play. So let's say we had an initial reading of 1 G, and then we took another reading and it was 0.707 Gs. If our accelerometer is 100 millivolts per G, then 1 G of input would be 100 millivolts of output. If our vibration level was 0.707 Gs, then we would have 70.7 millivolts of output. So let's plug these into our equation as V1 and V2, and we have the dB is 20 times the log of V2 divided by V1. V2 divided by V1 is 70.7 divided by 100. That comes out to be 0.707. So in your calculator, you would type in 0.707, hit the log button, hit times, hit 20, and you get minus 3 dB. So that change from 1 G to 0.707 Gs is a minus 3 dB change. And then we can look at the relation again to power. Power is voltage squared, so 0.707 squared is 0.5, and again, this is the half power point. Now, let's say you have the dV and you want to know what is the voltage ratio or what is the power ratio. You can use the 10 to the x button on your calculator. So for example, let's say you had an increase of 4 dB. What is the factor change in voltage? In other words, what is V2 divided by V1? So the way we do this is we would write down the formula. So 4 is our dB, and that equals 20 times the log of V2 divided by V1. I move 20 over to the other side. I divide both sides by 20 to do that. So I have 4 divided by 20 is log V2 over V1. 4 divided by 20 is 0.2. And then in my calculator, I type it in like 0.2, then I hit the 10 to the X button, then I do equals, and what I end up with is V2 over V1, and that is 1.58 in this case. So let's say I had a 100 millivolt per G accelerometer and my initial reading was 1 G. My new reading would be 1.58 Gs because now that is my new voltage or my voltage ratio. Another place where you see dB is in sensor calibration curves. And usually plus or minus 3 dB is used to show the linear range of the sensor. So on the left side, you can see it drops down by 3 dB. And on the right side, we're looking at the point where it goes up by 3 dB. And in between those 2 points is what we call our linear range. And depending upon the sensor you buy, within that linear range, it might vary by 5 or 10%. All right, thanks for listening to this very short presentation. Now it's time to test your knowledge. So please go to the website shown on the screen. You can also take a photo of that QR code and take a short quiz and test your knowledge. Let's see how you did. And while you're up there on my website, why don't you have a look at my course schedule. I've got vibration category 1, 2, and 3 ISO courses with certification. I do in-person courses in Miami at Ludeca and in Houston at NVibe. I also do them live online via Zoom. And of course, I'm available to do private courses, either on-site or online. So please shoot me an email for pricing and availability. And you can find my whole schedule here on the website. Thanks again.